So can you hear me? Okay. All right. There might be some interruption in between because of network issues. So we'll resume. If it happens, we'll resume soon after. So don't worry about that. Okay. 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 So I'm getting a lot of questions and emails about issues that you guys are facing in assignment. So those who are attending today, so is there any issue that you are facing? Because I gave almost the complete code. The last contract hour. Okay. So how many of you are still facing any problem with the assignment? So are you all able to do that?
1 minute. Sir, just inform to the students 10 to 15 minutes it resume.
Okay.
Okay, sir. Thank you, sir.
Okay, so if there's a network issue and the connection is gone, okay, it will resume in 10 to 15 minutes. Okay, so don't leave if it happens anytime. Okay, it will resume in 10 to 15 minutes if it happens. There might be some interruption during some network issues. So the complete code, almost 90% of the code is given, and there is no alternative. Okay, you have to do that either clustering or classification. Okay, and the code is almost there. It's 90%. It's just have to fill some parameters and continue. Okay, and one thing that someone was telling about was single linkage in clustering. So in the original assignment this was given, so I've changed it to, now you know that I've changed it to some other external matrix. Okay, so this is not something that you have to do. The silhouette coefficient is not something you have to submit. So this is not correct. Instead of this, you have to submit some other external scores which have been uploaded in the course page. And those who are doing the clustering part, in the agglomerative clustering, okay, in that what I saw today was when you apply the fit method, that is when you do, so first of all what you do is you'll get x from wet dot fit. So this will create the fit underscore transform. So this will create, so this is common to both clustering and classification problems. So this is the function fit underscore transform, and inside this you have to give the list of files, the f list. Okay. So this will transform the list of files into the TF IDF matrix, term document matrix. Okay, so you'll get X from here. Okay, and when you use the agglomerative clustering, instead of X, okay, to the function, to the fit function of agglomerative clustering, so you'll give X dot to dense. Okay, don't give X directly. it will give some error because the agglomerative clustering in scikit-learn it doesn't work with sparse matrix. So X here is sparse matrix. So convert it into a dense matrix. Dense matrix means a complete matrix where zeros are also filled in. Okay. So once you do like this, fit. This is you'll create agglomerative clustering. Let's say plus CLUS. Let's call it plus. So plus dot fit will be on X dense. Okay, X dot dense. The remaining part is all same as what you have done with k-means. Okay, so k-means can work with sparse matrix. So you don't have to convert this X into 2 dense for you don't have to apply the 2 dense method in k-means. Okay, but for agglomerative clustering, you have to convert it into 2 dense into that dense matrix. So X dot 2 dense has to be applied, where X is your term document matrix. Okay, so I think this is more than enough. You have to do something, right? So it's an assignment. So do something yourself. Okay, and so fit transform will first convert the list of files into term document matrix. Okay, and that we are calling X, capital X. Okay, and then either that capital X or X the dense matrix. So capital X is sparse matrix. So for k-means that can be directly used, X can be directly used, but for agglomerative clustering, X dot 2 dense. Okay, just apply X dot 2 dense, and then you can fit on that agglomerative clustering. Okay. So some couple of lines you have to fill up, not more than that. And then once you have got the labels, how to get the label? It was mentioned before in the class before that. Okay, the labels you can easily get class dot labels underscore, and once you get the label, you can easily give the y which is already available here from the y dot append. So this y is nothing but this y that you got from here, and lab is the labels. So I'm just calling it lab. It is labels that the clustering has given to each example, okay, or each data point. So that's all. So in all the cases, either k-means or agglomerative clustering, you have to use the same function. So this capital ZZ is not there. Okay, I think it's there by mistake. I was working in VI, so this ZZ method come there when I save the file and quit. Okay, so in the input mode itself. Okay, so this capital ZZ is not there, so don't copy this. Okay, this is not correct. ZZ is not there. Now what remains in the assignment for you is to just fill up a couple of lines. Okay, and even those lines I have told already. So number of clusters you have to experiment with. Okay, so try with a lot of numbers of clusters, say from 2 to 10 or 2 to 20, whatever is mentioned in the assignment, and then also experiment with min df. Okay, min underscore df. So this min underscore df, we can set it to say 2. So this will be the parameter of tf id vectorizer. So this function will have min underscore df somewhere here. Okay, so we can set this min df to 2 or maybe to 3 and 4. Okay, and you'll see that for one of them it will give the best score. So it may be the case that, and again for agglomerative clustering, usually with the single linkage. So these are again options available. Just go there, go to sklearn website and check it. Okay. So single linkage, complete linkage, average linkage, word linkage, all these are available. Okay. And when I checked it, the average was giving the best score. Okay, but you have to try all of them. And also min df. Okay, try for different values of min df and see which gives the best score. Okay. So min df is nothing but how many documents, in how many documents should a word be present to consider it as a part of vocabulary. Okay, so only those words. So if let's say min df is equal to 2, then only those words which are at least in 2 documents. So the min df is minimum document frequency. Okay, so in how many documents should the word be present so that it is considered as part of the vocabulary. Okay, and okay, and what is the word that you are referring to? Someone is asking what is the word that we are referring to. So what are the words in the documents? So we have email documents. If you go inside those files, we have all emails. Okay, so we have created the list of all files in file list, f list. So when you give input is equal to f list, input is equal to file name here, we are giving f list. Okay, f list we are giving as argument to tfidf to the fit underscore transform. Okay, so fit underscore transform will take argument as a list of files, and that you will give f list. Okay, so that files, all the files are containing words. Okay, okay. So so each document here is an email. Okay, so in how many documents a term is present? So if the word is not present in, let's say min df is equal to 2, and if the document is present in only one, if the word is present in only one document, then it will not be considered as vocabulary. It won't be taken into account. Okay, further it will just be ignored. So only those words which are present in at least 2 documents. If min df is equal to 3, then only those documents will be, only those words will be considered which are present in at least 3 documents, and so on. Okay. So f list you have already created, remember. Okay, and along with f list we have also created the y. So now you know the names of the files. So f list is nothing but name of the files, the complete path and name of the files. Okay, so f list is name of the files, and also we are also setting the corresponding y's. Y's is the label. You are giving just the directory name as the label. Okay, so now you know that the f list and labels are going together in 2 different lists, but the corresponding positions are same. Okay, and that is what you wanted. Okay, so when you run this properly, provided that all the paths are correct, you will not get any error. So we are giving proper paths. So this path here is path to the directory called to classify. Okay, so here remember that we are using the same to classify.zip file. Okay, so inside that you will have 5 folders. Okay, so let's call it to classify, and inside that you have 5 folders like some AST or some small names are there. So I don't recall the name. I'm just writing AST something like this. Okay, so path will be path to this to classify, and don't forget there's a slash forward slash at the end here everywhere. Okay, so if you're getting an error, maybe you have having some wrong, maybe you're not given slash or something. Yeah, so you have to define f list. Okay, so if you're getting f list not defined, then define it. So I'm not defining it, but you have to do that yourself. Okay, so F list and Y, you must have defined them as lists before this, then only you can use it. That I'm written in the code. Later use OS source. So this is later after you have defined everything, imported all the required modules, functions, and defined all these lists, F list, Y, and all. Okay, all right. So today is just a review session. We'll just review some of the slides that we have studied already, because these are the important topics, most important topics, and these have been discussed after the mid semester. So I've taken some of the slides from those topics, and we are just revising those. Okay, so these are topics which we have discussed after mid sem. So before mid sem, whatever we have discussed, uh, I have not taken those slides. Okay, because those are not are related to classification and clustering. So those are related mostly statistical methods, and how to use Python, how to use scikit-learn. So basics were covered before the mid semester, right? And then main part was covered after mid sem. Okay, this question: how to access the content of a file for which we have created a flist array? Why do you need to access that? Here in this code, you don't have to access the code. Okay, so input is equal to file name itself will do that for you. So just give the list of the files to tf idea vectorizer.fit method. Okay, so when you call dot fit, give the flist as argument. So it will automatically do that for you. Okay, you don't have to manually do everything. Once you given the file list method, it will just take all the files and do that for you. Okay, so just give flist. Flist is your list. So just give the name of the list. Okay, flist as argument to the fit underscore transform. Okay, that I told at the beginning, fit underscore transform, and inside that give flist, right? Flist in this case, flist. Okay, so if you have any doubt now, so refer to the documents which are available. Just search for append. What is append? What is tf idea vectorizer fit transform? All this. Okay. So anyway, I think now the doubts are clear. Is there any doubt remaining? Okay, Manmohan is saying not yet cleared. What is not cleared? So once you have defined your vectorizer like this, the vec method like this, okay, fill the remaining part. Then you have to call vec dot fit underscore transform. Okay, and to this you will give the flist as argument, because that is your file list. Okay, so this is what you will call after this. You will call after you have defined this properly, complete this code. Okay, so min df you have to define, or stop words is equal to English maybe. Okay, when you have defined this properly, everything is done. Then you call this fit underscore transform. Okay, so this will create a vocabulary and do the appropriate counts for you. Okay, so vec is a vectorizer. Okay, so if you do print vec, you'll see all these output. Yes, you'll see all the outputs through the vectorizer. So vectorizer is not your list. Okay, it is a vectorizer. So it will show the some parameters, what are the arguments, all these things. Okay. So once you have done up to vector transform, so this means you have created your X. So this will save in X, capital X. So this is your term document matrix. Okay, after this, just perform the algorithm clustering or the k-means clustering, and the code for those have been given earlier in the earlier sessions. Okay, so because now you have X, you have Y's, just do that and test them. Okay, and for agglomerate clustering, instead of using X directly, you have to use X dot to dense, okay, which will convert it to dense output. All right. Okay, which one is Y? Y is here. Y is the list here. Small y. Okay, that you have already created a list of y's corresponding to these files. Okay. Okay. So in clustering, you will not use y directly. Only to evaluate the clustering, you will use y at the end. Okay. So for clustering, y is only used during evaluation at the end when you use print adjusted underscore rand score or other scores. Then that time you will be using y because you want to compare y with the clustered labels and then see how much they are matching with y. Okay. So in clustering there is no train test. Okay, I think you have not attended earlier lectures, so attend all the other lectures, then you'll understand. Okay, so now let's go forward and do the some revision. Okay, so decision tree induction. Okay, so if you have any more doubts, just please post to the forum. Okay, we'll not spend more time on going through line by line the assignment. Okay, it's already been explained in sufficient detail. Okay, so in the decision tree induction, what we learned was about we learned mainly the information gain based attribute selections. That is the attribute, which attribute to select at each instance, which attribute to select to be split. Okay, and we saw in this example of whether a person will buy computer or not, depending upon certain features like age, whether he's a student, and what is his credit rating. So these are some of the features which are available, and there was examples, some examples with these features and the labels, whether he has bought the computer or not, whether he will buy a computer or not. Okay, so you want to predict, you want to create a classifier which will predict whether the person will buy or not, depending upon certain set of features as input. And we discussed in detail about the information gain, that is entropy based method. Right? So entropy of any split is given as minus P log P, and where this will be calculated for every split or every different label, each label. Okay, so every class or label. So initially, when you just know the class labels, you know how many classes are what kind, then the initial entropy will be minus P log P for, let's say, positive, negative, or yes, no. So minus P log P, how many? So probability is nothing but it will be counted based upon it will be calculated based upon the count of the positive category, count of the negative category. Okay. So we saw the example of this here. So this is the label in which there were some no's, some yeses. So I think there were 5 no's and 9 yeses. In total, 14 examples are there. Out of this, 9 were yes and 5 were no's, right? So the initial entropy will be, so what is the probability of yes? Minus 9 by 14. Okay, so log of that. So minus p log of p. So minus 9 by 14 log 9 by 14. Then again add to that the negative. So that is 5 by 14 log 5 by 14. So minus 5 by 14 log 5 by 14. So when you add these two, you get the initial entropy. Okay. And then for each split, for each of the possible splits, 1, 2, there are 4 possible splits here. Maybe based upon age or income or student or credit rating. So which one to select as the root node right now, right? Because we are just starting, so just like the root node. So you'll again calculate what if you split on age, what will be the resulting entropy, okay. And what if you split on income, what will be the resulting entropy, what if you split on student, what if you split on credit. So select for, so calculate the resulting entropy if you split on each of these the features, and then you will select the one with the least entropy. Okay. So again, this is the initial entropy, and this is the entropy of the resultant. So we have discussed all these earlier. So to go into more detail, how we calculated this entropy, you can just refer to the slides. Okay, maybe I'll just discuss one of them in some detail. So let's say you're trying to find the entropy for the split on age. So this is the age split. Okay, this is the age feature. So what if you split on age? What will be the resulting entropy? That is what you want to find out. Okay. So here you can see that age has how many different kind of. So it's a categorical attribute. Okay, and how many different kind of attributes are there? Or how many different values are there for this attribute age? So you can see there's youth, there's a middle aged, and there's a senior. So there are 3 possible values. Okay, for age. So when there are 3 possible values, then you count for each. What is the count for each of these values? Okay. So for example, for youth, you can see that how many youths are there. So 1, 2, 3, 4, 5 youths are there. Okay. How many middle aged are there? You can see that there are 4 middle aged. Okay. So that means 5 plus 4 is 9. That means remaining 4 are seniors. Okay. So 5 youth, 4 middle aged. Okay. And 4 seniors. Oh, sorry, 5 seniors. So 9 plus 5 is 14. So there are 5 youths and 5 seniors, and 4 middle aged. Okay. So then to calculate the resulting entropy, what you do is just calculate the probability of say youth first. Okay. So probability of youth is, so count of youth is 5. So the probability of any randomly selected person having age of a youth is 5 by 14. Okay. Now that you have selected their youth, what is the resulting entropy for that youth? Okay. Now, so for that youth, for all the available examples with youth as age, then you calculate entropy. So for entropy again, you will look at the labels, the distribution of labels. Okay. Now for youth, now you only have to look at the youth table, youth rows. So these are youths. These are youths which are available. This is available. Okay. So in this, you will just look at the distribution. So you have 5 youths. So what? How many of them are no's and how many of them are yes? So you can see that there are 2 yes and 3 no's. Okay. So out of 5, 2 yes, 3 no's. So entropy will be minus 2 by 5 for the 2 nodes, 2 nodes, so 2 by 5 log 2 by 5, and for 3s there are 3 by, okay, there are 3 nodes and 3s and 2 nodes, so total 5, so 3 by 5 log 3 by 5. Okay, so entropy is always based upon the distribution of labels or classes, plus or negative. Okay, but before that you have to multiply it by the probability of that particular value for the attribute. Here in this case it is 5 by 14. Okay, and similarly you will do the same thing for say middle aged. So middle aged are like here 4 by 14. So 4 by 14 is the probability of middle aged, and then inside that middle age how many of them are yes and how many of them are no. Based upon that you will calculate. Okay. Okay, I think Manmohan is still doing the assignment. Okay, so please let's take it offline. So just send me the mail or in the course page. Okay, someone will answer there. Okay, or maybe I'll answer. So just post your code in the course page. Okay, don't mail me directly. Just post in the course page so that more people can have a look. Okay. Okay, now focus on these parts. Okay, entropy and all attribute selection measures. So 4 of them are middle aged. So what should be the inside value? Now tell me. So 4 is the 4 by 14 is the probability of selecting a middle aged. Okay, now once you have selected the middle aged, what should be the inside value inside the bracket now? Okay, so the end term is like 45 marks. Okay, so this matters more than assignment. So you should understand about all these things. So middle aged, there are 4 yes and 0 no's. So what is the entropy now? So that means 4 by 4 are all yes. So 4 by 4 log 4 by 4 okay minus log 0 by 4 log 0 by 4. Now one more thing here for the calculation purpose we assume that log of 0 is 0. Okay, and anyway so this part will be all 0. Okay, so this is for middle aged. Now for senior, what should be the outside probability for senior? Again is 5. There are 5 seniors out of 14. So 5 by 14 is that a randomly selected person will be a senior. Okay, so what is the distribution now? Distribution of class within senior. So there are 3 yes and 2 no. One, two. There are 3 yeses for senior. Okay, and there are 2 no's. One is here, no, and 1 no is here. Okay, so there are 2 no's and 3 yes. So out of 5, 3 no's and 2 yes. So 3 yes and 2 no's out of 5. So 3 yes is minus 3 out of 5. Minus 3 by 5 log 3 by 5, and then 2 no's also are there out of 5. So 2 by 5 log 2 by 5. So this is how we calculated the entropy. if you have split on age. And the answer we got is 0.694. Okay, so we can calculate information gain from here by subtracting this info age from info D, initial entropy minus the resultant entropy. So initial entropy is much more, 0.940. Currently now we have entropy of 0.694, that is entropy has decreased. Okay, so remember that entropy represents the information required, how much more information is required. Okay, so initially you required 0.940 bits of information, and now after splitting you would require 0.694 bits of information. That means you have gained some information, right? Because now the requirement has decreased, has come down. Okay, so that information gain can be calculated by subtracting the initial entropy by calculating initial entropy minus the new entropy. So 0.94 minus 0.694. Okay, so now that means it requires less information. And if you think about it, you now you require less information, because if you split on age, okay, you will get one of the chunks. For example, for the middle aged, you are actually now sure that for the middle aged person, you know the label for sure it is a yes, right? And for others also we have improved. Okay, so initially what you had was how many yes and how many no's were there? There were 9 yes and 5 no's, right? Okay, so the split was like 9 by 5. So you're very uncertain whether any randomly selected person will buy or not buy computer. So that is initial, because you don't know anything about the person. So initial entropy means you don't have any other information apart from the distribution of the class, that is 9 positive and 5 negative out of 14 people. Okay, so that is your initial entropy. So you require a lot of more information. So initially you have 0.94 bits requirement. Okay, but once you know the age of people, okay, now you have some information, right? That means you have gained certain information. Now you gained information about age of a person. Okay, so once you gain that information, obviously you have gained something. So the information required should now decrease. Okay, so that is the theoretical stuff behind that. Okay, so now the information required, or the entropy, is 0.694, because now you know the age of a person. So as you gain more information about the person, you'll see that the entropy will keep on decreasing, or the required information will keep on decreasing, right? Because you are gaining more and more information about the person. For example, if you know the person is a middle age, now you know that you will buy computer. Yes, all 4 are yes. So you have got that information. Okay, and for youth and middle aged, still it is not. It is kind of even 2 by 5, 2 by 5, and 3 by 5, 3 by 5. But still, you have decreased that uncertainty when middle aged was there. Okay. So you can, based upon the information gain, you can decide, or directly you can decide based upon the entropy. So whichever feature out of these 4 has the least entropy, select that to split. Okay, in this case, as it happens, if you calculate completely, you'll see that. So for age, the gain was 0.246, and for others, the gain was not as much. Okay, as much as for gain when you split using age. So age will be used as the splitting criteria, because here the gain is the most. Okay, or if you just want to use entropy, you'll see that entropy is the least for age split. Okay, so entropy is the least when age was used to split. So the same thing, because you are subtracting that, so the least subtraction means the makes most gain. Okay, so this 0.694 was the least out of these 4, and when you subtracted the least from 9.94, you get the maximum value or the maximum gain. So 0.246 was the maximum gain. Okay, so this was the attribute selection measure based upon entropy. Now, if you look at the code for sklearn, okay, you'll also see that is the default value is here. There is not entropy. Even though entropy is available, you can select entropy, but the default value is Gini. Okay, so when you use the decision tree classifier, I think it's part of the assignment. Okay, so in that you will see that by default it is Gini as the splitting criteria. Okay, so you can select Gini and entropy both and try both and see which one is giving good result for your problem. Okay, so this is the split when you use age. So once you use age to split, because now we have selected age because it has the most information gain. So you will split like youth. There were 5 youths. There were 4 middle-aged, and then there were 5 seniors. So they split like this. So again, assuming this is now available, this is now your available table. Okay, available data. Now again you will repeat the same process for each table where you require. Okay, so for this table you don't require anything else because here you have got all the labels from the same class. Yes class, right? So you stop here and just label it as yes. So that means if the person is middle aged, you know that he will buy computer. Okay, so in the future if any data comes in which the person is middle aged, you can immediately say that he will buy computer without checking for other attributes. But if it's youth or senior, then you have to again check for some more attributes and increase this tree. Okay, in reality, you will not keep on creating the tree until you get a single node or until all the nodes are the same label. Okay, you will stop somewhere before that. Okay, you will stop somewhere when maybe the number of class, the individual class should have maximum value or something, right? So minimum, maybe you will stop when the node size becomes equal to 5 or equal to 10. You will stop there. Okay, that is number of examples in each node falls below some level. You stop, and you will see in this sklearn you have a lot of these parameters available to you, which that you can select, right? So either the minimum number of examples or the decrease in entropy, all these things are available to you. So you may stop before that, and in practical you actually stop before getting to the leaf node. You just cut down the tree, you prune the tree. Okay, tree pruning. Okay, now there's a question: do we need to do Laplace smoothing for these cases in exam? Which cases? We are talking about Laplace smoothing. So Laplace smoothing we did in the case of naive Bayes classifier, right? Naive classifier. So there, if you have to do some document classification, yes, you might have to do Laplace smoothing. Otherwise, you will get some probability 0, and you will not be able to progress further. So Laplace smoothing when you are working with text. Yes. Okay. And regarding books or slides, I think slides are enough. Okay, so slides and video lectures and whatever I have discussed during those video lectures, those are enough. Okay, and many of these topics are from the reference books, but whatever you have discussed, okay, these are enough. Whatever assignment I have given to you, the quiz, whatever material we have discussed in the class, that is enough. Okay, so the Gini entropy that we discussed is calculated in a similar way, but the formula is different. Okay, so initial Gini is calculated as 1 minus summation of pi squares, where pi is the probability of every class. Okay, so initially we have 9 yes and 5 no. Okay, so pi will be for each class. So for positive class, what is the probability, and for negative class, what is the probability? So you will calculate this Gini, initial Gini, as 1 minus some square of those probabilities. So what is the square of positive? So positive 9 by 5. So 9 by 5 square, and for negative it is 9 by 14. For negative it is 5 by 14. Okay, so this is the initial Gini, and then you can just calculate the later Gini just by substituting formula. Okay, so for age, if you want to split, let's say you want to calculate Gini, if you split on age, and again look at the probability of each of the possibilities. So youth has 5 by 14 probability like earlier, and what if you split on youth? What will be the Gini? So when you split on youth, you had 3 no's and 2 yes, right? So that was so you calculate Gini again, 1 minus. So Gini formula is always 1 minus summation of all the probabilities squared. So there are 5, 2 of them are positive, so 2 by 5 squared, plus 3 of them are negative, so 3 by 5 squared. Okay, so this is when the person is youth, and then similarly you can calculate for others. Okay, there's a question. Open book questions will be theory based or calculation based questions. Okay, so mostly they are calculation based. Okay, you have to do some calculations. Okay, so they are problem solving kind of questions. You cannot give theory because it is open book. If you give theory, you can just look at the slides. So you can take the slides also, right? Can you take the printout of slides? Yeah. So if I just give from the slides itself, because I'm giving everything from whatever we have discussed, so you can just copy it, right? So I'll give problems in such a way that you cannot directly copy. Okay. So the syllabus is the full complete syllabus. Okay, but the post midterm is the most important part because pre midterm you have already given midterm exam, right? So it will mostly focus on the post midterm. Okay. How is the split of the question between problems and theory? I don't remember. Okay, but just I know that majority of them are problem solving kinds. Okay. Okay, hi sir. Gini age minus Gini youth, Gini mid plus Gini senior. Final Gini index. Yeah, so you'll calculate for youth, then you'll calculate for middle aged. So you'll see that for middle aged again it will be 0. So similar to that. Okay, for middle aged you will be like here it is 4 by 15, and inside again you'll have 1 minus some values, 4 by 4 square plus 0 square, so it will be 0. Okay, so 1 minus 1 will be 0, and the plus for seniors again 5 by 14, so 5 by 14 Gini for that. So that is the Gini when you split on age. Okay, initial Gini was you calculated this 1 minus 9 by 5 square minus 9 by 14 square minus 5 by 14 square. Okay. So when you subtract initial Gini minus this Gini, look at what is giving me the maximum gain. It's similar to the entropy waste, but here it's calculating Gini, which is again a different kind of attribute selection metric. Okay, so you have to take your calculator to the exam. Okay, and the calculators have logs and all available, log base 2 and all. Okay, so take some, don't take your basic calculators, take some calculator in which you can calculate log of 2, because all these measures entropy, all these they use base 2 logs. Okay, so there are some problems. There will be some problems in which you have to calculate all these logs and all. Okay, or at least write down the formula. If you don't want to calculate, you can just write down the formula so that you can see whether you are going in the right direction or not and give you marks based upon that. Okay, so even if you are not able to calculate completely, write down everything just before calculations. So whatever was there in the formula, fill those formula and then submit. Okay, calculation is good for DS specialists. For me, too tough. No, it is not tough. It is easy. So I'm not giving in the exam. You'll not get like these big tables. You get some smaller tables and smaller numbers. But you should know the basics. Then only you'll be able to calculate even that. Once you know the basic, even calculating big tables will be easy if you have computer or calculator. Okay, but if you don't know the basics, then even you cannot even calculate small tables, right? Okay. Okay, so we'll take a small break and then I'll meet in 5 minutes.